Most of the 24 hours. Hi, I'm George Crump, lead analyst with Storage Switzerland. Thank you for tuning in today. Joining me is Manish Apte, senior staff software engineer at SanDisk. How you doing?
I'm doing good. Thanks for having me.
Yeah, you're welcome. You're in lead development for the vSphere projects over at FlashSoft, right?
You're right.
I think that's really good timing because one of the things we're starting to see is in the VMware environment, clearly users have decided SSD is a way to solve a lot of problems.
Absolutely.
And so now, and I think we're also starting to see this gravitation toward caching being the at least most direct way to solve the problem because you don't have to get into some of the manual stuff. So we're starting to see people put caching either in the storage, in the SAN itself, or on the network. And I'll tell you what's really gaining in popularity though is to really put the cache right here. In your mind, why are we seeing such the interest in server-side caching in VMware environments today?
Sure. So as you pointed out, you can do caching at different levels in the food chain, if you will, when the storage I/O travels from the virtual machine all the way down to the real storage where the data is. But having caching closer to the application and inside the compute node, which is the server where the hypervisor is running, avoids the delay and the complexity and the latency that the SAN introduces.
Right, so I take all this out of the equation.
You take all of the SAN and the complexity and the latency out of the picture, and when the data is in the cache that is available in the compute node, the IOs are satisfied much faster than having to travel them all the way back to the storage.
Okay, so my only concern here is that opens up a little bit of a can of worms for us, right? Because one of the big values of a virtualized environment is I might want to take VM7 that I have drawn up there and move him over here. How do I handle things like vMotion?
So what we have done is our software is actually in the form of two components. One that gets installed on the ESX compute node as part of the ESX kernel. And when it is available on multiple nodes, and when virtual machines move from one node to another, we have enough technology in the form of the way we hook into the I/O path that we can detect that, and we do the right thing in terms of getting rid of the cache when a virtual machine moves from one node to another or comes back to the original node where the data might be sitting in the cache, but it might be stale. So because of the way we hook into the ESX storage stack, we have the ability to detect that and do the right thing where the cache we purge the cache when it needs to be, and we preserve the cache when it doesn't need to be purged.
Okay, so in this case, you might evict all the cache out here, or preserve it in case VM7 comes back.
Right.
Okay, well that's very interesting. So specifically in your guys' world, how does the FlashSoft product install into the vSphere environment?
As I mentioned, our software is shipped in the form of two components. One component is a kernel mode driver that gets installed on the ESX kernel. And there is a separate component to manage our software that gets installed in the vCenter client as a client plugin. And once you have these two going, and when you take the vCenter client plugin and point it to the ESX node where our software is running, you can configure our software, which is very simple, and that's how you allow the administrator to use our software by being as transparent as possible.
Okay, so from the vCenter standpoint, it's just another tab, if you will, in the vCenter interface?
Right, that's what the client plugin does, and that makes it very easy for the administrator to use our software, which is running in the kernel, in the background, pretty much transparent to all the other activities that are happening in your ESX ecosystem.
And then is there a specific type of SSD that I have to buy from you guys here, or how does that work?
No, actually, we designed the software such that we could use any vendor, any SSD, and not just any vendor, but any form factor SSD such as a SAS, SATA, or PCI. So in that sense, we are completely agnostic to SSD hardware.
Okay, so that means that here, if I've got a real performance sensitive situation, I could go PCI here, but over here I could go SAS SSD.
Absolutely. So when you install our software, and the first thing you do is you select an SSD device. And that device is really, we don't really care whether the device is actually physically connected to the machine in the form of a SAS, SATA drive, or PCI. All we need is a device name that you get to choose during the SSD configuration phase. And that's a one-time setting. And once that is done, even if you reboot your VMs, even if you reboot your ESX node, we'll continue to use that SSD device.
Okay, and then one line, just cleanup item. I I don't need to install anything inside the virtual machine itself?
Absolutely, and that was one of the key things because if we can keep going up in the food chain, you can definitely go and install components in the guest. But that adds a lot of complexity in terms of ability to have the cache available on multiple operating systems, as well as the fact that now cache is going to consume a lot of resources. So we consciously decided not to use the guest agent route and just decided to keep the cache in the hypervisor at a point where it's a good place in the storage stack where it is not too fine-grained, that is too closer to the VMs, not too coarse-grained, that is too away from the, rather towards the storage array, so that where we are is a point where we can easily accelerate and give the most effectiveness of the cache.
Okay, and then so is the impact here that I can increase, I guess the big thing is it really gives me the ability to increase virtual machine density, right? Because I've removed this, so much of the I/O here, right?
Absolutely. So what we have done is, because of the fact that the data is served from an SSD which is on the compute node, most of the I/O is not traveling, and now you can do more work on the same node without having to increase the storage, the CPU, or the RAM.
Right.
And because of that, now you can run more VMs, which otherwise were sitting idle just waiting for I/O.
Okay. Yeah, I think that's huge because what we see often in many environments is there's tons of CPU power to go around.
Absolutely.
It's the storage I/O bottleneck that really kills you.
Right. So with our software, your CPU consumption might be 20–30% max because most of the time the application is waiting for I/O. With our software, we can easily go 60–70%.
Okay, awesome. Well, thank you very much for joining us today.
Thanks for having me.
All right, I'm George Crump, lead analyst with Storage Switzerland. Thank you for tuning in.